100,000 tons of American naval power about to float again. USS Gerald R. Ford, America's most advanced aircraft carrier ever constructed, sitting inside massive dry dock for 15 months. Critical repairs complete, systems upgraded, crew ready. Now comes engineering challenge matching original construction, getting this colossal warship back into water. Ship stretches longer than 3 football fields. Displaces weight equivalent to 50,000 automobiles. Cost $13 billion to build. Moving it from dry dock to open water, precision operation requiring perfect coordination. One mistake could damage vessel worth more than some nations' entire military budgets. 1,000 workers involved. Specialized equipment deployed. Every calculation checked and rechecked. This isn't routine maintenance completion. This is America's newest supercarrier returning to active duty after emergency repairs that shocked naval community. What forced this technological marvel into dry dock so early in service life? How do engineers move something this massive safely? What does this mean for US naval dominance globally? Let's dive in. 1. The beast USS Gerald R. Ford. Before understanding repair significance, need understanding the ship itself. USS Gerald R. Ford, not just Navy's newest carrier, most technologically advanced warship ever constructed. Specifications staggering. Length, over 1,100 feet. Weight, 100,000 tons fully loaded. Crew, 4,500 sailors. Aircraft capacity, 75+ aircraft. Power plant, 2 nuclear reactors providing 25 years operation without refueling. But size alone doesn't tell complete story. Ford-class carriers generate 3 times more electrical power than older Nimitz-class carriers. Why massive power increase matters: enables revolutionary technologies impossible on previous ships. Electromagnetic aircraft launch system. Replaces steam catapults used since 1950s. Launches aircraft smoother. More frequently. With greater precision. Pilots experience less physical stress. Aircraft suffer reduced wear and tear. System can launch 270 sorties daily, 33% more than previous carriers. In combat, that increased capacity could mean difference between victory and defeat. More flights equals more strike missions. More reconnaissance. More air superiority patrols. Advanced arresting gear. Stops aircraft weighing up to 50,000 pounds from landing speed to complete halt in just few hundred feet. Dual-band radar system, AN Spy-3 multifunction radar combined with AN Spy-4 volume search radar. Can simultaneously track hundreds of targets while guiding missiles and coordinating air traffic. Despite being significantly more capable, Ford requires 600 fewer crew members than Nimitz-class carrier. Advanced automation handles tasks previously requiring dozens of sailors. Saves money on personnel costs, reduces demands on berthing, food supply, life support systems. Every detail optimized for maximum efficiency. This ship represents 4 decades of naval aviation advancement. First entirely new American carrier design since Nimitz-class commissioned 1975. 2. The crisis: what went wrong? So what forced this marvel of engineering into emergency repairs so early in operational life? Problems began during post-delivery sea trials early 2018. Ford conducting critical tests at sea. Suddenly, alarms erupting in engineering spaces. Main thrust bearing failed. When one fails, entire shaft line compromised. Ford immediately shut down affected systems. Carefully returned to port using reduced power. Investigations revealed failure caused by machining errors during manufacturing process. Company called GE produced defective bearing. Manufacturing mistakes created weaknesses unable withstanding operational stresses. Serious problem because thrust bearings aren't simple parts you swap out quickly. Huntington Ingalls Industries, shipyard that built Ford, received contract repairing faulty equipment. Losing carrier for repairs created significant operational challenges, but Navy had no choice. Better fix problem correctly now than risk catastrophic failure during combat operations. 3. The dry dock process. moving 100,000-ton aircraft carrier into dry dock, engineering marvel by itself. Can't just drive ship into garage. Entire process requires precision planning, specialized equipment, incredible skill. First, ship must be carefully positioned above dry dock while still filled with water. Multiple tugboats, sometimes 6 or more, maneuver massive vessel into exact alignment. Positioning accuracy measured in inches. If ship not perfectly aligned, could damage dry dock or ship itself during draining process. Once positioned, workers secure ship using massive wooden blocks and support structures. These supports must be placed at precisely engineered points along hull, distributing ship's enormous weight evenly. Getting this wrong could cause structural damage worth hundreds of millions of dollars. Then comes draining. Over 100 million gallons of water slowly empty from dry dock. Even smallest misalignment could cause premature wear or another failure. Tolerance levels incredibly tight. Measurements in thousandths of inch. Meanwhile, Navy took advantage having Ford in dry dock conducting other maintenance and upgrades. When you've got carrier out of service anyway, makes sense addressing other issues and installing improvements. Teams worked around clock performing hull inspections, servicing underwater systems, upgrading various components. 15 months of intensive work. Over 800,000 man-hours on thrust-bearing repairs alone. 1,000 workers. Skilled craftsmen working in difficult conditions, often in tight spaces. Always aware their work directly impacts national security. 4. The Rollout engineering precision. After 15 months intensive work, moment finally arrived. USS Gerald R. Ford ready to leave dry dock. But getting ship back into water, just as complex as dry docking process. Rolling out begins with most critical step. Flooding dry dock. Massive pumps, reverse flow. Water from James River starts filling enormous dock. But this not done quickly. Flooding happens gradually over several days. Why? Forces involved tremendous. Water rushing in too fast could damage support structures, create dangerous currents around ship. As water level rises, Ford slowly begins to float. Engineers monitor ship constantly, watching for any unexpected movement or settling. Ship must lift evenly off support blocks. If one section lifts before another, could cause structural stress. Entire process carefully choreographed, monitored from multiple positions. Once water level matches surrounding river, massive caisson, essentially huge watertight door sealing dry dock, removed. Opens dry dock to waterway outside. But Ford still can't just sail out. Ship must first be inspected, systems tested, everything verified as ready for movement. Then tugboats arrive again. These powerful vessels carefully pull and push carrier, maneuvering it out of dry dock into main channel. Despite their power, tugboats move forward incredibly slowly. Not talking miles per hour, more like feet per minute. Every movement controlled, deliberate. Crews manning tugs among most skilled mariners in world. Understand currents. Know how Ford will respond to every nudge. Work together with perfect coordination. One mistake could damage ship or dock, potentially causing hundreds of millions dollars damage. Watching this process in person, absolutely breathtaking. Ship this size seems almost impossible. Defies common sense that something so massive can float. Yet there it is, slowly emerging from dry dock. Ready resuming mission defending American interests worldwide. 5. Testing AN certification. Just because ship floating again doesn't mean ready for operations. Every system must be tested, every repair verified. Crew must complete extensive training and drills. After leaving dry dock, real work begins. Ford must undergo rigorous testing before Navy will certify it ready for deployment. Not simple tests. Comprehensive evaluations of every critical system under realistic conditions. Propulsion system receives particular attention. After all, thrust-bearing failure brought ship to dry dock in first place. Engineers conduct tests at various power levels, monitoring temperatures, vibrations, performance metrics. Bearings must prove they can handle full operational loads without any indication of problems. Ship conducts fast cruise exercises while still pierside. During fast cruise, crew operates ship as if at sea, but ship remains tied to dock, allows testing communications. Damage control procedures. Combat systems. Every operational capability in controlled environment. If problems arise, easier to fix while ship's still in port. Next comes sea trials. Ford heads out to sea for extended periods, conducting increasingly complex evolutions. Ship runs at flank speed, maximum velocity. Makes tight turns. Stops and starts. Every maneuver tests propulsion system and repairs made. Navy officials and Huntington Ingalls representatives monitor everything closely. But propulsion, not only focus. Electromagnetic aircraft launch system must be tested extensively. Deadload testing involves launching sleds simulating weight of various aircraft. These sleds shot off deck repeatedly. Stressing system under realistic conditions. Only after dozens successful launches can system be certified ready for actual aircraft operations. Advanced arresting gear receives similar scrutiny. System must stop aircraft weighing up to 50,000 pounds from landing speed to complete halt in just few hundred feet. Forces involved enormous. System must work perfectly every time. No room for error when pilots' lives online. Radar systems, weapon systems, communication systems, all undergo own testing protocols. Ford must prove it can detect threats, engage enemies, coordinate with other ships and aircraft, maintain communications under all conditions, including electronic warfare scenarios where enemies attempt jamming or disrupting signals. Conclusion: strategic significance. Successful repair and return of USS Gerald R. Ford carries enormous strategic significance. Aircraft carriers remain most powerful symbols of American military might. Our ability projecting force anywhere in world, when carrier operational, provides options no other military asset can match. Single carrier strike group can influence events across hundreds of thousands square miles. Presence of carrier changes calculations for potential adversaries. Nations think twice before taking aggressive actions when American supercarrier nearby. This is deterrence, preventing conflicts through strength. Ford's advanced capabilities make it even more valuable than previous carriers. Ability launching more sorties means sustaining combat operations longer without support. Reduced crew requirements mean lower operational costs. Improved reliability. Once early issues resolved, means more time at sea and less time in maintenance. Consider global situation America faces today. China rapidly expanding navy, asserting claims over disputed waters. Russia continuing challenge American interests multiple regions. Iran regularly threatening international shipping lanes. North Korea remaining unpredictable and dangerous. Protecting American interests. Promoting peace through strength. Ship floating again. Systems operational. Carrier ready. America's Navy remains world's finest. USS Gerald R. Ford proves it.